The one question that should come up in discussions of the presumed greenhouse effect, but doesn't, is the one that relates to the apple on the cover of the Twilight novel, and the apple as discussed in the Da Vinci Code. The Da Vinci Code has apple as an answer to one of its riddles, and it has to do with Isaac Newton's discovery of the theory of universal gravitation, and the idea that this knowledge is somehow forbidden and kept suppressed by the Church. That may not be true, but there are church-like entities like governments and corporations, things that pretend not to be churches, but are functioning like them, and are handing down doctrines for us to believe today that are essentially denying the existence of gravity. Liquids and gases aren't the cause of the warm Earth, but the result of it, and work in almost every way to carry heat away from the Earth by currents in the crust, oceans, and atmosphere. The only thing that counters these influences is not a greenhouse, but gravity. A greenhouse is something that operates to some extent like an anti-gravity device. It's something that keeps warm air, which in the absence of other influences will expand and become less dense than the air above it, from rising. Normally warm air should rise, but a greenhouse has walls and a roof, which, although the gas inside is not kept under pressure, provide enough of an impediment that the warm air, once it's heated, does not leave. The problem with the idea of a greenhouse gas is that just because the gas is absorbing outgoing radiation from the Earth does not mean that it's going to warm the Earth, because even if it does get warmed up more than the gas above it, it will rise and take the heat away. So you need a barrier that will prevent this mixing or sorting of gases, in which the less dense stuff goes on the top of the pile and the denser stuff goes on the bottom of the pile. There is no solid lid over the Earth in reality. We have no greenhouse glass over us, and what makes a greenhouse work is its glass, not its gas. Gravity, if you have a sufficient thickness of the column of air, can compensate for the lack of this effect to some extent, because if you pressurize a gas at the same time that you shine light on it or warm it up otherwise, you can compensate for what would otherwise be the expansion of the gas. There are two ways to heat a gas. You can irradiate it or expose it to a heat source in some way, but you can also do work on it. The reverse of this is when you let the air out of a bicycle tire, and the air coming out of the tire will feel cool, not only because it's creating a breeze on your hand, but also because it's expanding as it comes out of the tire. The reverse case is that if you force a gas into a confined space and increase the pressure on it, you can heat it up. As you go toward the center of the Earth, the pull of gravity gets steadily stronger, and as you go into a thinner and thinner atmosphere, the pull of gravity decreases. So on the fringes of the atmosphere, gravity is not as strong as it is down near sea level, for instance. Also, as you go down in the pile of air, there is more and more air weighing down on a given portion of air than there is higher up. As you get thicker and thicker, there's more pressure from the air above you. This means that there's a compensating influence on the tendency of air to rise, because when there's a large, thick column of air, the bottom of the column of air will be getting pressurized, so it can withstand a small amount of heating before it starts to rise and takes the heat away. This means that gravity pulls the denser air down and pushes the less dense, warmer air up. But it does not exert its force evenly on the entire column of air. It exerts its force more on the lower portions of the column of air than higher up. And the difference in the case of dry air is about 9.8 degrees Celsius per kilometer. So if you've heated a certain parcel of air all the same amount, all the way through, by shining radiation on it, putting it in contact with warm ground, and so on, the portions that have been heated exactly the same amount will be different temperatures at the bottom of the pile of air than at the top. The top of the pile of air will generally be about 9.8 degrees Celsius cooler after a kilometer of thickness than the bottom, assuming that it's not humid. This means that gravity is the hidden force, the forbidden knowledge which isn't discussed when people talk about the way the Earth heats itself. Gravity is the thing that keeps the Earth warmer than it would otherwise be, heats gas even in the absence of sunlight, and keeps the warmer gas underneath the cooler gas.